Okay, so let's just see if you got 1 and 2 right. So it says write each polynomial in standard form, then classify it. That means name it. So looking at number 1 on the review, isn't this already in standard form? Highest degree to lowest degree. So now we can name it, and remember you name it by the highest degree and the number of terms. So the first name comes from the highest degree. So what is this called? A cubic. So degree 1 is linear, degree 2 is quadratic, that makes sense. Degree 3 is cubic, degree 4 is quartic. Remember, 4 quarts in a gallon, quartic. And then 5 is quintic. Remember, if you have 5 babies, it's called having quints. Then after that, there's no special name. It's 6th degree, 7th degree, 8th degree. Then the next name is the number of terms. So there's 3 terms, so that's called a trinomial. Everybody remember this. The last name is always "il." Monomial, binomial, trinomial. Then after that, it's just polynomial of 4 terms. So this is where people get these confused. They'll say weird things, but just be careful. Okay, number 2. We cannot name this because it's not in standard form. That's going to be the first thing you do on the final exam, is if you have to name something, we're asked to write each polynomial in standard form. That would mean multiply it out. Be careful when multiplying this out. So when you did multiply this out, how many of you took this suggestion that I give and either multiply these 2 together and combine like terms, or multiply these 2 together and combine like terms? Okay, awesome. Which ones should I multiply together? It doesn't matter. These 2? Okay, so you're saying I like that. Let's focus on multiplying these 2 together. So we would distribute. That's x squared plus 3x minus 3x minus 9. Combine like terms. X squared minus 9. Now we have to multiply all of that still to x squared. So now x squared times x squared is x to the 4th. X squared times negative 9 is negative 9x squared. So now it's in standard form, highest degree to lowest degree. So now we'll name it by the highest degree and the number of terms. So the highest degree is 4. What's the name for 4? Quartic. 4 quarts in a gallon. It's quartic. And then there's 2 terms, so binomial. Yeah. The first name always comes from the degree. Good question. Okay, questions on that? Okay, I need you to get answers for 3 through 5 so we can check them. Go, go, go. So number 3 is just addition. Don't let the parentheses throw you off, because on the final exam, they'll make sure to put an answer where you unaccidentally multiplied it together. Because a lot of people do that, but it's addition. So you're just combining like terms. So you should have got that as an answer. Number 4, subtraction is one of the most missed problems on the test because people forget to distribute that negative through. So that's really negative 2x squared plus 5x plus 6. And now you're just combining like terms. Then on number 5, it is multiplication. They're right next to each other. There's 2 terms, there's 3 terms. So you've got to distribute. Focus on 2x, distribute 2x through by multiplication. Focus on negative 1, distribute that through by multiplication. So I'm going to give you another second. example. So it says write a polynomial in standard form with these given zeros. You don't need to take notes, but you better watch. So remember, if I say to you find the zeros, that means solve it. You'll have x equals this, and x equals this, whatever, however many answers you get. So this one we're going backwards. We're given the solutions, we're given the zeros. It says what was the original polynomial? So remember, when solving a polynomial, we factor it down to linear factors if possible and then solve. So we have x is equal to 2 as a solution, x is equal to 1, and x is equal to -1. So before we had those solutions, we had linear factors that were set equal to 0. So instead of having it equal to 2, we want it set equal to 0. So x minus 2 equals 0. We've got to use algebra to get to the other side of the equation. Not -1, so x minus 1 was equal to 0 if 1 was a solution, and we add 1 to both sides. So x plus 1 was the linear factor if x equals -1 was a solution. Now, before they were linear factors that were each individually set equal to 0, they used to be multiplied together. These linear factors used to be multiplied together and set equal to 0. So then from there, we would then keep going because we want the polynomial in standard form, not in factored form, which this is factored. So now we would multiply 2 of them together and combine like terms. So this would be x squared plus x minus 1. We'd combine like terms, x squared minus 1. And then we would multiply that to our x minus 2. So that would take double distribution. And we'd write it in standard form. So we would write it like this. So this was the polynomial that had those solutions. So if we were given something like this and asked to find the solutions, we would factor. This one would factor by grouping because there's 4 terms, notice. So just saying. So we went backwards, we found the polynomial given the zeros. Front page. So it says, find the zeros of the function and state their multiplicities. Either people, when we took this test, this is the second test we took, people either completely just got them all right or people bombed it. So you want to watch. So if it says find the zeros, doesn't it mean solve, everybody? We spent months learning how to solve every type of polynomial, correct? Everyone we tackle differently. So the first thing we always do when trying to solve is factor it, see if it factors. So look at this one. Now we factor them all differently, but the first thing we check for, is there something we can pull out right here, right now? We pull out x squared, correct? Divide by x squared, divide by x squared, divide by x squared. Then we write what's left in our parentheses. Here, we're going to have x squared left. Here we'll have minus x left, and here we'll have minus 2. So then you'd say to yourself, okay, this is factored, but does that factor even more? It's a quadratic. So we'd say what multiplies to be a times c, what multiplies to be -2, and adds up to be b, which is -1. 1 times 2, -2 and +1, correct? Now, can we quick factor? Yes, because our leading coefficient is 1. So this whole piece factors to be x plus 1 and x minus 2 from those two things. And then we can't forget we had x squared. So now we're finding the zeros, so we solved by factoring. So isn't this technically x squared? And then we have our x plus 1, and we have our x minus 2. So linear factors, you'll set each of them equal to 0 and solve. So we have x equals 0, x equals 0, x plus 1 equals 0, x minus 2 equals 0, solve for x. So x equals 0, and then we would subtract 1, x equals -1, we'd add 2, x is equal to 2. So how we would write this is x equals -1, 2, and 0 with a multiplicity of 2, because it happens twice. Right? Okay, now next one, look over here. This says find the zeros. Don't just start multiplying it out because that's what you think you should do. Say to yourself, what am I supposed to be doing? It doesn't say simplify, it says solve it, find the zeros. We always find them by factoring, so this is already factored. So now just set each of them equal to 0 and solve. So when we get x equals 0, we'll get x equals 3 with a multiplicity of, good, because it happened 5 times. And then we get x is equal to -1 with a multiplicity of 2, because it happened twice. How would I solve? It says find the zeros of the function and state their multiplicities. So everybody, because you could see one like this. So if it says find the zeros, very good. You're remembering. I'm very proud. 1, 2, 3, 4. If there's ever 4 terms, we try factoring by grouping, and if that doesn't work, then we try a different method. So we pull out the greatest thing in common here, which is x squared. So then left, divide by x squared, divide by x squared. Left would be x minus 1, correct? Don't say nothing. We're way past that point. Then out right here, we'll pull out negative 4. Left is x, divide by negative 4, divide by negative 4. Left is x minus 1. If these safe havens aren't the same, it did not factor by grouping, and you go back to here and say, I've got to solve this differently. Does everybody remember this? So now we'll pull out the greatest thing in common, which is x minus 1. Don't make the mistake of saying there's 2 x minus 1s. No, we're factoring out x minus 1. Then left is x squared minus 4. Correct? You pull out x minus 1, then didn't it divide out? Last was x squared minus 4. Then you'd say to yourself, is this factored all the way? Nope, that factors more. Well, it multiplies to be a times b, negative 4, and adds up to be b, 0, 2 times negative 2. We can quick factor it, so our leading coefficient is 1. So we have x minus 1, and then this piece factors to be x plus 2 and x minus 2. So we just solved by factoring. Well, we're not done solving, but we're going to solve by factoring. We factored it, so we get x equals 1, x equals negative 2, and x equals 2. Correct, everybody? No multiple roots there. Okay, one more reminder, because I saw this on your review, and so I needed to add it on there, because this was one we learned, and it's one of the methods. Yes. It's a U substitution. Way to go. Way to remember. I know that you learned this differently. Your teacher taught it differently, and so we can talk about how you could go about doing this. So I taught this one differently. Good. It's a U substitution, so it's quadratic in form. So we know that x to the 4th is x squared squared, correct? Minus 10x squared plus 25. So we know that we can make a U substitution here. We're going to say, let x squared be U. So instead of putting in x squared, wherever there's an x squared, we're replacing with u. So this becomes a u. So we have u squared minus, and that becomes a u, minus 10u plus 25. Now it's a quadratic, so we can solve the quadratic by factoring. So what multiplies to be a times c, what multiplies to be 25, and adds up to be negative 10. Won't it be negative 5 times negative 5? So this factors to be u minus 5 times u minus 5. So u equals 5, u equals 5, correct? Now those aren't our solutions because that's u. We need x. So remember, x squared equals u, so x squared equals 5, and x squared equals u here, so x squared equals 5 again. Solve for x, so we would square root both sides, correct? Everybody? Yes. So we get x is equal to, way to remember, Cassandra, plus or minus square root of 5, correct? And we get x is equal to, we'd square root both sides, x is equal to plus and minus the square root of 5. So it says state the roots and state their multiple multiplicities. So we get x is equal to the square root of 5 with a multiplicity of 2, because it happened twice, and x equals negative square root of 5 with a multiplicity of 2. So hopefully that's a good reminder for you, because it's been a long time. Sweet. So I want you to finish up at least 3 up through 9 and check them with me. On this, we know if we're solving, how many solutions should we have? 4 solutions. Did we have 4? Yes? Okay. So how many solutions will we have? Well, we had many solutions there. How many solutions should we have here? 3, guys, the highest degree. Did we have 3? And then check here. We should have 4 solutions, and we do have 4. So just make sure that helps you kind of check, am I missing anything? So number 10, it says use a graphing calculator to find relative max and min and the zeros. So luckily we get to solve this one using all of our calculator, and we get to sketch it using our calculator. You will have to have listed out the max values, min values, and the zeros, the solution where it's crossing the x-axis. So go to the graphing calculator. Go to y equals, because we're trying to graph this. So y equals, if you have anything in there, clear it out. And type it in with me. So we have x to the 4th. Look at your paper. I'm not going to say it. And it will graph it wrong if you put negative signs instead of subtraction signs and stuff like that. Okay, so once you know, if my window's not good enough, like look at my window, it is not good. I can't see anything that's going on. So I need to fix my window. So think about it. I need to see further down here. So I need to go down on the Y value. So I go to window. I go to Y min, because I need to see down further. So I'm going to change it to like -20. And then I don't need to go as high up as 50. I'm just going to try a few things here. I'm going to hit graph. Okay. So I can see what's going on. I can see the bounces pretty good here. Does everybody have their window in a place where they can see their bounces? You should all be doing this, not watching me do it, but doing it. First part for students. So we have a min, a relative min, and another relative min, meaning low point, low point. So everybody, I'm going to find one of those mins first. So I'm going to just say, I'm going to find this minimum right here first. So you'll do second trace, then go down to minimum, hit enter. Now it's asking you for a left bound. That means I need to know where you're wanting me to find the minimum of, over what interval. So we're going to scroll left of the minimum value so that it knows where we're talking. So do you see how anywhere left will work? Hit enter. Now it says right bound. It's saying, where do you want me to find the min? So between what values? So now we got to scroll right of the min. So now it knows between that interval, I'm going to find the lowest point. So I hit enter. And then it says, do you want me to guess? We do want it to guess. Hit enter again. Now it tells us our minimum is at -4.275. But do you see the E? E? Everybody. E means that you've got it times 10 to the -7th. So that means you got to move this decimal back 7 places. So it's pretty much 0.0000000. So it's not pretty much 0. We're going to call this 0, -3. So you'll write, one of my mins, you'll do like this, one of my mins is 0, -3. Now you'll pull up your calculator again. You'll have to start over. You're going to say, now let's find this min. You'll do second trace again. Go down to min, enter. Left bound, you've got to be left of the min, anywhere left. So I'm to the left of that low point. So I hit enter. Now it says right bound, anywhere right of the min. So it just knows what interval it's finding that low point for. Hit enter, hit enter. Our other min is at 2.8. Look, there's no e's. So this is exact values. 2.8, 0.9, and then -12.2. So 2.9, comma, -12.2. So your other min is at, already forgot. Was it, okay, 2.9, -12.2, right? Okay, let's draw in those values. Over 0, down 3. Boom. Over 2.9, almost 3, down 12. So down here somewhere. Okay, sweet. Now let's find the max. So so max is the highest point, which is right there. So you'll do second trace. And you'll go down to maximum. Now it says, where is the max? Like, where's a left point, left bound, left of the max? So you're telling it which interval to find the highest point of. So I'm left of the max, I hit enter. Go right of the max. Enter. You want us to guess? Yes. So our max is at 0.8, or 0.9, basically. 0.9, -2, basically, right? If we're pretty, like if we graph -1.9, it's going to be pretty much -2. So let's just call this 0.9, -2. So our max, 0.9, -2. So that's over 1, down 2. That's our max, -2. Now we got to find the zeros. That means where it's crossing the x-axis. Now that's solving it, and we're told that we're allowed to use our graphing calculator. If it doesn't tell you, you can use your graphing calculator. You've got to do it by hand, because then you'll find exact values. This is letting us approximate decimals. So we're going to find the zeros where it crosses the x-axis. So you'll do, let's find this 0 first, right here. So you'll do second trace, go down to 0, hit enter. This is left bound, so we've got to scroll and be left of the 0 so it knows where it's, which 0 you want it to calculate. I hit enter, right bound, scroll right of the 0. So then it just knows which interval, which 0 it is. So negative 0.6, comma 0. So it's crossing the x-axis. Our zeros are at negative 0.60. So we're going back 0.6. So it's coming up and crossing, goes up to the max, down, and it's coming up. Let's find the other 0. So you'll go second trace, go down to 0. Left bound, so let's be close to the 0. Left of it though. Come on, come on, come on, come on. So left of the 0, enter, right bound. Oh, I found him in. Second trace, 0. Left bound, enter. Right bound, enter, enter. So our other 0 is at 3.70. So, boom. Now I've graphed it. Everybody good? Okay, sweet. Continue. Yeah.
I didn't see the graphing.
If it says solve by graphing, doesn't that mean just plug it in your calculator and then do second trace zeros? You know what I mean? You can't ever forget the quadratic formula.
I know how to write it, but I forget the words. Yeah. But I know how to write it with the song. Third root of b squared minus 4ab all over 2a. What is my math? Oh, over 2a. Get it?
Minus.
All over 2. And it's the square root. Negative 2 squared. Plus or minus outside of the square root. No, really.
So with these ones, guys, it says find the real roots by graphing. That means by graphing, and we only want the real roots. Because look up here, everybody. Just a reminder, isn't there 4 solutions for this? Yes, there's 10. Okay, so there's 4 solutions, but if you graph it, it looks something like this. So there are 4 solutions, but they never cross the x-axis, so none of them are real. So there's no real roots. Now we were only asked to find the real roots, so that would be our answer. If it said find the solutions, then there'd be 2 imaginary solutions, and we'd have to solve by hand and using a different method. But it just said find the real roots. So on 15, your first step would be to get it set equal to 0. So I'm going to bring these over this way. Subtract x squared, subtract 3, subtract x squared, subtract 3. So we have 0 is equal to x cubed minus x squared minus 8. This one does cross the x-axis. So you'll find that by graphing. Okay, everybody, I'm going to this next thing to remind you. It says, determine if each binomial is a factor. So I'm going to review a couple things with you. Let's just do 18. So if it's a factor, that means if we divide the polynomials using synthetic or long division, the remainder will come out 0 because it's a perfect factor. Does that make sense, everybody? Remember doing that. So I'm going to use synthetic division. So remember to use synthetic division, you'll set the linear factor equal to 0 and solve. So x equals -2, correct? So we put a -2, we draw our little box thing, and then you put the coefficients, the number in front of the variable, and you've got to check this. We start with degree 3, then it went degree 2, degree 1, and a constant. If you're missing anything, any degree, you got to put in a 0, okay? So we put a 1, and then a 1, and you got to do the signs with it, -10, and then +8. And then remember, you drop this one straight down. So drop it straight down, then you multiply up. 1 times -2 is -2. We add straight down. Basically, there's a 0 here, you add straight down and you get 1. 1 times -2 is -2. We add straight down and get -1. -1 times -2 is +2. We add straight down and get -8. -8 times -2, +16, and we add straight down and we get 24. So then remember, we went from a cubic, we divided this using synthetic division once, didn't it become from a cubic down to a quadratic? So x squared, x, constant, remainder. Or we work backwards, remainder, constant, x squared, right everybody? Because the end thing's always your remainder. So our remainder didn't come out 0. So this is not a true factor. If it was a true factor, the remainder would come out 0. So we would say no, because we had a remainder. So hopefully that reminds you how to do synthetic division. So if we were going to write out if we were just doing synthetic division, it asked us instead to do synthetic division. Our answer would be x squared minus x minus 8. Our remainder is 24, so we'd say plus 24 over what we were dividing by, which was x plus 2. This is how we would write the new polynomial. Okay, next thing, it says, list the possible rational roots. Guys, this has been a long time ago, and this is a lot to remember, so watch very quickly. Remember that what we're doing is we're listing the possible solutions that are rational, meaning that can be written as a fraction, correct? The solutions that are nice and pretty. So it says, list the possible rational roots. This was found doing P over Q. So remember that this is Q, the first coefficient is Q, and the constant, it has to be the constant, is P. So you list out factors of P, anything that multiplies to be 5, plus or minus 1, plus or minus 5. Q, list out every factor that could multiply to be 2, plus or minus 1, plus or minus 2. So the possible solutions that are rational, P over Q, the possible rational roots will be all possible P's divided by Q's. So 1 up here divided by 1 down here is 1. Plus or minus 1 is a possible rational root. 1 divided by 2, so 1 over 2. So plus or minus a half is also a possible rational root. 5 divided by 1 is 5. Plus or minus 5 is a possible rational root. And plus or minus 5 divided by 2. So guys, the possible rational solutions these are the only possible rational solutions. So then remember, so if it says list of possible rational roots, that would be all we have to do. Those are the possible rational roots. Now I'm going to remind you of how to find any actual rational roots. So now we're going to find out of those, are there any of those that are the actual solutions of this polynomial? So remember that I let you graph it. So everybody, we will graph it. Okay, can someone help me remember this so I don't have to pull it up again? Yes, 3 minus 6 squared plus 2x. So we would graph it. We go to y equals 2x cubed minus, what was it? Anyone? But it wasn't the one on your paper, I don't think. 2x cubed. Okay, you remember the second one, Cassandra remember the third one, and Joe remember the last one. Got it? Who can remember? Okay. Minus x squared plus 2x plus, oh dear, Joe. Bless your heart. Okay, we hit graph. So looking at it, we're using a cheat. We're pretty much cheating here. We look and say, where does it look like it's crossing the x-axis? -1. So that's the first one we're going to test out. Correct, everybody? So it looks like the actual rational roots will be -1. It looks like, but we got to make sure. So we put in, we're going to test -1 first. We're going to do synthetic division with our polynomial. So we have a cubic squared linear constant. We're not missing anything. So 2, -1, 2, and 5. Drop down 2. 2 times -1 is -2. We add straight down and get -3. -3 times -1 is 3. We add straight down and get 5. 5 times -1 is -5. We add straight down and get 0. Oh, good. So our remainder is 0. So x equals -1 is a rational solution. Correct, everybody? Did it ever cross the x-axis again? No. So aren't our other two solutions not going to be in any of these? Or else it would cross at one of those values, correct? Everybody understand? So when it says finding the actual rational roots, the only one is -1. Now, because it only, what? There's 3 solutions, but we're asked, so we got to be really careful here. There are 3 solutions, but the only rational root is going to be one of these, like it's these values. So it only crossed the x-axis one time, right? So it was at -1. We knew it was. So now here's the thing, though. It says find any actual rational root. So this is the only rational root, but there's 2 more roots, correct? So then remember from here, how we would do it was, this is 2x squared now, minus 3x plus 5. If we were going to find the rest of the roots, wouldn't we solve this quadratic by quadratic formula? Does that make sense? So this was the only rational root. But all of the roots, if we needed to find them, we would then use quadratic formula or some other method. Does that make sense? But if it crossed the x-axis in a few more times, we would want to check these by synthetic division to see which other rational roots we have. Does that make sense, everybody? Okay. Or we could have just looked at this, and if there were more rational roots, that would factor. Remember how, and then it would factor, and then those would also be able to be written as a fraction, which means rational. So we could solve the other 2 roots by factoring. But that doesn't factor, so they must be imaginary or irrational solutions. Okay, so do 20 through 22. I'll give you. The only time we can use synthetic division is if it is linear and 1 in front of x. So if we were asked to divide x cubed plus 2x squared plus 3 by this, you couldn't do synthetic division. Does that make sense, everybody? You would have to do long division. So you might want to go back and review long division just in case. But if it was just x plus 1 and they said do long division, we could literally just do synthetic division because there's a 1 in front of x. Does that make sense, everybody? Because synthetic division is easier. Okay. All right. So everybody, a review of this. It says a polynomial. I cannot tell you how many people missed this on the test, so you need to pay attention. A polynomial with rational coefficients has these given roots. That means solutions. So we're given solutions again. Given these solutions, it says find any additional roots, which means find any additional solution. So remember the rule very carefully because it's going to be multiple choice and I have a bad feeling that most of you are going to miss it. The rule is if you have an imaginary solution, its conjugate is also a solution. If you have an irrational solution, its conjugate is also a solution. That is not true for whole numbers. That is not true for fractions. Does everybody listen to that? Okay, so let's look right here. Given the solution 3 and 2i, what else is a root? Negative 2i. This is an imaginary root, so its conjugate has to be a root. Not negative 3 though. 3 is not imaginary, and 3 is not irrational. Everybody good? They will put on the test negative 3 as an option. Do not choose that. So right here, what are any additional solutions? No additional solutions. They're not imaginary. They're not irrational. Everybody good? Yeah? Okay. What about right here? What additional solutions would we have? Negative square root of 3 and 3i, because that's irrational. That is imaginary. So the conjugates also have to be a solution. Remember that rule. Yes.
What about
5 square root of 3 is irrational, right? There's a square root of 3. That means it can't be simplified. So that's irrational. So negative 5 square root of 3 would also be a solution. And positive square root of 2. Okay, so everybody look up here. It says write a polynomial in standard form with these given roots. So you're going to have to take that knowledge and extend it. So if given roots, that means the given solution. So we're given x equals 1 and x equals negative 2. Are there any other solutions? Are the conjugate a solution here? No, these are not imaginary, not irrational. So then we'll work backwards. So we'll have x minus 1 times x plus 2. Does everybody understand why? And then we would double distribute and combine like terms, right? Okay? So notice something. There's 2 solutions, so your final answer should be degree 2. Okay, everybody, we have x equals 1 and x equals 3i as a solution. Any other solutions? Even though it wasn't given, what else is a solution? Negative 3i. So now we have to actually write the polynomial in standard form. So we're going to work backwards. So we'd subtract 1, x minus 1, correct? We would subtract 3i, x minus 3i. We would add 3i, so that's x plus 3i. And now when we multiply this together, well, we've got to make sure that we always, so now multiplying this out, remember if you're smart about it, which you will get it wrong, guaranteed, if you try to multiply this in here and then distribute, you will get it wrong, promise. We always multiply the conjugates together first just because it simplifies really pretty. Watch. X times x is x squared, right? X times positive 3i is positive 3ix. And then negative 3i times x is negative 3ix. And then right here's where people mess up. Negative 3i times positive 3i is negative 9i squared. Don't my middle terms cancel out? So we have x squared minus 9i squared. And then what is I squared equal to? So this is x squared minus 9 times negative 1, right? Not plus, it's times. So x squared plus 9. So that simplified to be nice and pretty. X squared plus 9, which makes sense. If we solve that, wouldn't we get plus or minus 3i? We'd subtract 9. It would be negative 9 square root it. So then we're going to also multiply in x minus 1. So now we would double distribute and combine like terms, if any. Everybody good with that? Okay. So much to remember. So how many roots? You should not miss this one on the final. How many roots does this equation have? 5. It's the highest degree. That means how many solutions? Roots mean solutions. How many solutions does this have? 12. How many solutions does this have? 2. So everybody, one last example here and then we'll call it good. Yeah. So it says find all the zeros. That means solve it completely. So there's 4 terms. We could try factoring by grouping, but do you see how it doesn't work? So then we have to resort to P over Q, find possible rational roots. No, it does. And then we would get, so this is 28. Do you want me to keep going on 28? Okay, so we list out possible P over Q. So this is Q, the 1 is, correct? This is P, everybody? So plus or minus 1 plus or minus 2 are factors of P, and factors of Q are plus or minus 1. So all possible P over Q's is 1 or 2, correct? Now I would type it into my calculator, hit graph. So I do that, and I see it looks like it's crossing at 1. So isn't this where we put a 1 in, test it using synthetic division? So we put a 1 in, a 5, a -4, a -2. We drop down 1. 1 times 1 is 1. Add straight down is 6. 6 times 1 is 6. We add straight down and get 2. 2 times 1 is 2. We add straight down and get 0. So our remainder is 0. So x equals 1 is one of our solutions. Does everybody understand? How many total solutions are there? 3. So now what I'm going to do is say, okay, I have this new polynomial. I just did synthetic division, and it went from a cubic down to a quadratic, or remainder constant x squared. So we have this, x squared plus 6x plus 2. Now we have to keep solving it. Let's try solving by factoring. What multiplies to be 2 and adds up to be 6? Nothing. So we would solve this by quadratic formula. And how many solutions does the quadratic formula give me? 2 more. So then how many solutions would that give me? 1, 2, 3, and we found them all. Okay, I'm not going to go through the quadratic formula. You do that at home. Questions on that? This video will be posted as well. So you would do the same thing for 29. Notice we are like, it says solve it. You don't know how to solve something with 5 terms, and like there's no greatest common factor. So you say, okay, fine, I have to do P over Q, which is always my last resort, right? Okay, the key is uploaded, once again, so you can go through and see this. Okay, so we've got to go over this one because it would be a shame to miss these ones just because you didn't know how to use your calculator. These ones don't take any math. All you have to do is calculator. So it says, write a polynomial whose graph passes through these points. So everybody, what you would do is go to stat and into edit. In list 1, you type in your x values. So you type in -1, 0, 1, 2. In list 2, you type in your y values, -9, -8, -7, and 0. Everybody remember how to do this? So do that real quick. If I bring up my calculator, I'm not going to remember those points. So you go stat, edit. In list 1, make sure you don't delete the list. And remember that clear doesn't work. You do have to hit delete. Or you can go up here and hit clear, but you cannot hit delete or you're in big trouble. So you can go up into the list and hit clear, but if you hit delete, you're in huge trouble. Okay, so now in list 1, you type in your, you have to scroll like this down, and then it will clear it out. Okay, in list 1, you type in your x values. In list 2, you go and type in your y values. Everybody do that. It's not if you, just clear doesn't work if you're down here. Okay, and then in list 2, okay, -9, -8, -7, 0. -9. Okay, then from there, you'll hit stat again. Over to calculate. Now we don't know what degree it is, correct? So let's try a linear. I hit enter, I enter through. Now look, r squared is 0.78. Doesn't that mean it's only a 78% good fit? Right? Everybody remember that r squared just means it's not what percent of a good fit. That's a horrible fit. So it's not linear. Hit stat, over to calculate. I'm going to go down and try quadratic. I hit enter. And look at r squared. It's 96% accurate. Better. So let's try another one. Let's try a few of them and make sure we pick the best fit. So calculate. Let's go down to cubic. I hit enter, enter. Oh, r squared's 1. Doesn't that mean it's 100% perfect fit? So we're going to choose cubic. Now look, it gives me the answer. So it's 1x cubed. And then it looks like 0x squared, so there'll be no x squared, 0x, and then -8. So that's x cubed -8 was my answer. Everybody understand? Okay, so then on 31, you gotta just type, this is the same thing, you'll use your stat key again, But here's what you got to remember. Read this. It says X is the number of years after 2000. So what would X be here? 4, correct? 4 years after 2000? You got to use the correct X or you'll get it wrong. This would be 7 years, 9 years, and 10 years after 2000. And then you would type in, so in list 1, that's what that would go. List 2, those would go. And then it says use a cubic model. So no matter what, we would just hit stat, calculate cubic model, write down the entire thing, right? Everybody remember? So then if I said to you, because it does say, then calculate what the production is in year 2025. So wouldn't we just type in, put 25 back into the function? X. Right? Wouldn't I just plug in 25 in for X? And it will give you the answer, the production answer. Everybody understand? Okay. All right, so we post